All right, hello. This is going to be the first time that I will be re-recording one of these, uh, but there was a lot wrong with the first one. So, just to get right into it, um, so we've still got the uh, the little brush here. It can expand out, expand in. It doesn't ever get bigger than the dimensions of the screen, but if you look at that, crazy. It now you can change the shape. Right now I've just got it set to the left and right arrow keys, up and down arrow keys, and space. I'll probably make a menu for it at some point, but this works, so that's what I'm doing. Um, and then on the side, I've got the elements all like the palette, it's called. Um, It's widened now, and the labels are all centered properly, and uh, they also work in release mode. And so uh, part of what I'm going to show you later is that we aren't. Uh, so we were using a debugging trait before to get the names of the different elements. And that is something that like really should only be used in development mode if it even like works outside of it. I don't even know. Um, but we've got it working properly now. Um, and then to go right over here, hopefully, yes, you should be able to see that. Um, so basically, I've got the implementation of new elements set up now. So as a simple example, stone. Uh, Stone is a constant. It is of type struct element. That's probably going to have its name changed at some point. And then it's got three fields. It's got the name, stone, which is where we get stone. Um, Gray, which is where we get the color gray. Um, and then tick. Tick is a function which takes a number of uh, arguments here that you can see. It takes a grid of struct element, a grid of uh, booleans, which uh, is not really important for this and is subject to change, but is currently how I keep track of which particles have been updated. And then it also takes an x and a y, unsigned integers. Um, and so for stone right here, we don't need any of those. So we're taking them all and then we're doing nothing with it. And that just means that stone doesn't do anything. Like it just sits there. But if we want it to do something, we have a function called basic movement, and we can call that if we want to within the definition of an element, and that's going to take the grid and the updated grid that we're calling here, and the purpose here is basically just to pass them straight through. And then the x and y coordinate of where this particular particle exists in the board. Um, and then a vector of directions, and a direction is just like um, up, left, up, up, right, all the way through down, left, down, down, right. Um, and this is basically going to be like it's going to go through that vector, and it's going to check in each of those directions by one cell to see if any of the uh, interactions that we pass it can apply. And if they do, then we execute that interaction. And that's what we pass here, is the interactions. So with that, here's an example. So with water, up here we define name water, color blue, and then we can give it water tick. Water tick is then defined right here, passing all that shit. We don't need to go over that again. And here we are calling basic movement, passing in all that shit again. And then we are passing it direction liquid, which um, is basically defined as somewhere up here. Yeah. Uh, Basically, what it does is it checks down first. It sees if any of the interactions apply. If they don't, then it checks down left and down right in a random order. If any of those interactions apply, it does them. If not, then it checks left and right in a random order again. Um, and then we have similar ones defined for powder, which is basically the same thing, but it doesn't do left and right. It just stops at down and then down, left, down, right. And then we've got one for gas, which is basically what liquid does, but upside down. Uh, and then we technically have all, but I don't know why you would use it because it favors up left. But all rand does kind of get used because it just does all of the directions but randomized. So there's no real bias there. Um, so we passed that. We passed the interactions. Um, and so within interactions, we have a few different types. We have swaps with, replaces, reacts to, coerces, and reacts with. Um, so swaps with basically says if 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 I am an element, I am a particle, um, and I am looking at another particle. If that type of particle, if that element is one that I can swap with, then I swap with it. Uh, if it's one that I replace, then I basically override its value. Um, if it's one that I react to, then I change to something new. If it's one that I coerce, then I change it to something else. And if it's something that I react with, then we both change our elements. I feel like, hopefully that was a good enough explanation. Just as for a few examples here, we've got so water, if it is doing its scanning and it sees a heater block, then it turns into steam. The water turns into steam. Um, if it sees air, smoke, steam, or oil, then it just passes through them, essentially. Um, if it sees lava, then the water turns into steam and the lava turns into stone. And if it sees molten glass, then the molten glass turns into glass. I believe we've got some examples of lava has a coerce. So if lava sees ice, it'll turn it into water. I thought I had one of these pulled up that has some reacts with. No, that I think we. Okay, yeah. So we had that. What was that? Anyway, I think you probably get the point. Replaces. Yeah, okay. I actually don't know if I currently have anything that like just straight replaces. Lava used to. Oh wait, no. Eater. Yeah. So Eater will just replace anything besides other Eaters. And then yeah, that's I think essentially it. You know, if steam sees ice, it turns into water. And then this default right here just means that we don't have any reacts with, we don't have any replaces, we don't have any of those others for this particular element. So that all is if we want to use basic movement, but we do not have to use basic movement. And an example of that is with clear. So whenever a clear element updates, it takes the grid that it's passed and it just clears the grid. And so if we go back over here, I can put a bunch of shit in here. And then, you know, put some water, rain some water. Sand is going to turn into molten glass, and then more water. And it's going to turn some of that into glass. All right, so we got a bunch of shit, right? I put clear, and it just clears the entire grid. A funny thing with this one is that if we do, let's just get one of these. If we fill the board with eaters, and then we just put a tiny little clear. Of course, it's not happening now because, of course not. But yeah, so the eaters will just eat the clear, and then these are just air. Like these are literally just air moving around. Um, so um, you know, not exactly supposed to happen. Um, but I I think it's fun enough that I'm probably just gonna keep it. And the chances are low enough of it happening anyway that if I literally just increase the brush size by one, like there's very, very little chance of all of these being eaten before any of them get a chance to update. So, like, you know, not impossible that I change that at some point, but I think it's fun enough that I'm just gonna keep it for now. And Yeah, I think that was essentially it. We got an example of something doing something that is not basic movement. We've got an example of something doing basic movement, and we've got an example of something doing nothing. Uh, and the big thing here was mainly just getting it so that all of these particles are defined in their own files, just for sake of like reducing confusion and overwhelm when trying to work on one particular particle. Um, and so I can do all my work on stone in this file, and then when I want to implement it, I just have to go into the elements module, make sure that it is uh, scoped right here, and then I have to use the constant stone. And then if I want it to be included in all elements, then I put it in here. And also I need to make sure that air is in here. And yeah, that's about it. This having to write it 3 times is still not ideal, but um, it's much better than the way I had it before, which was using an enum, and then there was, we were calling the method to get the color of each element on the enum itself, and so we had to have a match clause going through every variant of the enum to get the color of each, and then we also called the tick function on the enum, and so then in that one we had to go through a match statement of every single variant, um, and this way at least it's all pretty centralized, and the logic is then kind of sorted out into their own individual parts, rather than, if I'm trying to update sand and having to go to like 12 different places, I can go to one place, do 3 things, and then go to another place and do the rest of it, which is much better than it was before. So that's the big thing that I wanted to show off, is that there are certainly some improvements that can be made here, but I've gotten it to a point that I feel like I've mostly exhausted my options, and I think this is the one that is going to work pretty close to the best that I can get it, for now. And I'm, you know, reasonably proud of it. You know, I I I think it's fairly flexible in that it has some basic stuff set up for you if you want to use it, but you don't have to use it, and you have the option to like just do nothing. You have the option to do something inline, or you have the option to define a function for it, um, and any of them work. Some things I'm likely to change. Color uh, may well also become a function. We will see about that as I find or don't find uh, use cases for it being a function instead of just a past, like, or just a stored value. I also want to have chances for things to happen still. Like that is something that I feel is definitely getting to the point that it's like a missing feature big time is like, if lava comes across ice, there should be like a chance for it to melt that we can define within that specific interaction. Um, so that's something I'd like to work on. And uh, hopefully, ideally, reducing some of the like uh, shit up here with the mod water, use water, all water. Um, and also, what I'm probably going to do, like right now, as soon as I stop recording, is for elements that do nothing, I'm just going to define a function probably in here somewhere uh, that just, or probably in here actually, that just takes all of the arguments and then does nothing, just so that you don't have to type the 4 underscores. You can just type do nothing or whatever, and it'll do the rest. Um, so yeah, that's my update. Um, as is, you know, uh, tradition at this point. Let's get a little smiley face. Actually, no. I want to let it live. So we're going to do out of just stone. And then we're going to put a bunch of eaters, and we're going to eat the smiley face. Put some like lava, and they'll eat it too. Um, Zombie. Oh wait, no, zombie. Yeah, so they are different. Just by the way, in case you were wondering.